Okay, so in this video, we're going to take a look at the domain and range. And of course, let's start off by making sure we define these words correctly. So the domain of a function, or I should say a relation of which a function is a sort of subset of, well, a domain is the set of possible x values, okay, that this relation might have. The range is the outputs, the range of possible y values. So this is really easy to illustrate if we consider a coordinate grid, okay? So if I had a particular function or relation, right, okay, you can see one illustrated here by that line, that red line here, look. So the domain is here. It's those possible values, look. So of course our domain is going to be from 1 to 5, and I know that because I can see those coordinate points there. My range, okay, well, this is going to be the outcomes of my function or my relation. That in this case is from -2 to 3, and that is it really. Now, of course, it's a lot far more challenging than that. We need to think about how we're going to write this, and we're going to write these in set notation. So the way of writing x is between 1 and 5 is as followed. We're going to open up some curly brackets, and we're going to say x is such that, and then of course we can write our inequality statement is between 1 and 5 inclusive, and that we should know already. We need to make sure we close them with some curly brackets. That is the correct set notation. So of course, if we're dealing with y values for our range, we would say the same sort of thing. Y is such that y falls between -2 and 3 inclusive. And just to make a quick point, the inequality sign includes the values because our diagram has these dots, and these dots mean we include that number. If that dot was not shaded in, we wouldn't include the number itself. Okay, so in summary, domain is our inputs, our x values. The range is our outputs, our y values. So let's have a quick look at another example. Here we have a relation, and it's just made up of these dots. So can we think about what the domain is going to be? Well, the domain is going to be the set of numbers -3 because of this, -2, -1 because of these two, look. Okay, not 0 though, because we don't have any of those dots or having an x coordinate of 0. And then we've got 1 and 2. All right, so there is our domain. How are we going to write that? Well, you can see below there, look, the domain is the set of numbers -3, -2, -1, 1 and 2. Now let's think about those corresponding y values when we think about the range. So what y values have we got? Well, let's draw some lines, look, to help us to understand. So we've got a -2, we've got a -1, we've got a 1, and we've got a 2 as y coordinates. So oh, and I missed one, didn't I? Look, okay, I've got this 0 as well because of that point there. So we can see the range is -2, -1, 0, 1, and 2. Okay, let's increase the difficulty now and take a look at another function. So this one is a relation that is defined as all of the points in that square there. Okay, so how would I write that? Well, the domain is the points that are between -1 and 0 because they're the possible inputs, the possible x coordinates. The range is the possible y coordinates, the output. So of course, the range is going to be the numbers between 0 and 1. So how do we write that? Let's just double check. We write the domain is x such that x falls between -1 and 0 inclusive. The range is that y such that y falls between 0 and 1. And that notation there is really important. Okay, let's try another one. Okay, I'll try to hide that answer for you so you can think about this yourself. So we've got this function. It's a parabola, a quadratic. The equation of this curve, look, is here. It is y equals -x squared plus 6x minus 5. So what could the inputs be? Well, any real number can be put in there, look, okay? As an input, we could have x is minus 100, or x is 25, or x is minus 4.67. It doesn't matter, anything that goes, we can put in, so that the domain is going to be all the numbers. The range of this, well, think about these outputs. Can we have a y-coordinate greater than 4? We can't, can we? Because we have this maximum point here, look, and after that line, look, we don't have any y values. There's no y values possible above 4. So our answer for our range is going to be that y is such that y is less than or equal to 4. Now, how do we write that perfectly? Well, we introduce a new symbol for the domain. When we say that x can be any number, we need to kind of introduce the set of real numbers, and we use this R symbol to help us to do that. So this statement that we have for the domain reads, x is such that x belongs to the real numbers. Okay, so this symbol here is belongs to. This symbol here is the real numbers, and that really means the numbers that fall on the number line. The range, remember, that means that y is less than or equal to 4 is, as we would expect, y such that y is less than or equal to 4. Okay, so let's move on. Let's have a look at another example. Now, I want us to keep the answer in front of us for this one, okay? We've got this diagram here, and we can see that we have a line, and when we have an arrow, this really is telling us that we extend on forever in that direction. Notice as well that the circle, that point that marks the beginning of the arrow, is open, it's not shaded, and that means that although we can't include the actual point 2 minus 1 in our thoughts, it's everything to the left and up from that point. So hopefully we can see already why those answers are there. The domain is going to be everything, every input, okay, to the left, isn't it? Okay, domain is our x values, so anything less than 2. So we can see how this is written. X is such that x is less than 2. The y coordinates define our range. Okay, now think of those y coordinates. Well, clearly we are going to be everything that is above minus 1. We can have y's in any y at all because we go on forever as long as it's above minus 1. And that's why we have this range here. Look, y such that y is greater than minus 1. Right, let's try another one. Now, this time we'll keep that answer hidden and see if we can think about this. So can you think about what is the range and domain? Let's start with the domain. Remember, the domain is the possible inputs, the x values. Well, again, because these arrows mean that we go on forever in both directions, we could say that x is such that x belongs to those real numbers. Okay, what about the range? Well, those are the y values. I am going to say is y such that y is greater than or equal to minus 2. We're not getting any y values underneath that minus 2, so that's why our range is there. Don't forget to close it with a curly bracket. We're done. Right, let's try and think about this question. So we've got an interesting function now, something a little different. Y is 3 divided by x. And if I were to draw that, it would look as the diagram does below. Now, there's a couple of features of this graph. What can't we input into this? Let's think about our domain first. Is there any values that we cannot input? Well, there is, because I cannot put 0 into this. 3 divided by 0 is not going to work. And of course, if you think about this graphically, at the point when x is equal to 0, we don't have a coordinate point. Every other one is covered, right up to as closest to that line as we can, but not 0 itself. So one of the things that we need to think about when we write a domain is that x, yep, does belong to the real numbers again. It goes off infinitely towards negative and positive infinity, but with one condition. X does not equal 0. And that is how we write that statement, with an equal sign with a line through it. Now, we'll have a look at the correct way to write this in just a minute, but I want you to think about the idea behind this before we deal with that notation. What about the range? So the outcomes. Well, whatever I put in as x, what outcomes can I expect to have as a y coordinate for all my different x coordinates? Well, clearly we can have all sorts. You can tell from the diagram and the arrows that y goes infinitely positive towards positive infinity and negative infinity. But again, with one exception. We're never going to get an outcome that is 0. There is no such number that when we do 3 divided by it, we ever get 0. And that is illustrated diagrammatically by there not being any coordinate point with a y value of 0. So this is very similar. Y belongs to the real values, but y cannot be 0. Okay, now we've got that roughly written down. Let's just make sure we take a look at how this is written. So x is such that x is not equal to 0. Y is such that y is not equal to 0. And we don't necessarily have to write the real numbers here because it's assumed, and it's not all of them because it's not including that 0. And that's why it's not been given in this particular example. Okay, so hopefully that's helped you to get an understanding of what the range and domain are. You may well see far more challenging questions than this, but that's going to get you started. Think about that domain being the input values, the x coordinates on any function, and that range being the outcomes, the y values of any function, of the coordinates of any function.